Welcome to this installment of the Secure Your DNS, Secure Your Network series. My name is Tim Rooney, Director of Product Management at Diamond IP, and the goal of this video series is to break down into bite-sized chunks the myriad ways the domain name system, or DNS, can be attacked or manipulated for nefarious purposes, or the ways that your network in general can be attacked, and how the DNS can be used as a defensive mechanism to help protect your network against such attacks. In this video, we're going to be talking about software-defined wide area networks, or SD-WAN. Let's start with an overview of SD-WAN. It's basically characterized by the separation of what's called the data plane from the control plane. Control plane is where your SD-WAN controller resides, and that is the area where all the control, configuration, and monitoring occurs, and it is then dispensed or distributed down into the data plane to configure your software-defined routers, which are the devices at the customer premise locations that interconnect to your wide area network for connectivity across your network. Now, these SD-WANs route the traffic for optimal performance and cost savings, and the way it can do this is because it's not necessarily just connected to your WAN, but it also supports multiple interfaces to 5G wireless, for example, VPNs, and also the internet, as we shall see. These various configurations provide the benefit of improving network performance by enabling the routing, the closest routing not only over a wide area network, but over multiple networks. It also provides the centralized provisioning benefit through the SD-WAN controller, giving you a single pane of glass perspective, and it also simplifies operations. Network cost savings can be achieved by reducing or eliminating the costly wide area network charges that you might be paying a service provider. So using other supplemental network interfaces enables you to distribute that cost and reduce the concentration paid to any given single service provider. If we look at the traditional wide area network topology, it's often been characterized as having on the left a number of sites within your organization interconnected to a private wide area network, which enable the communications among the various sites in your network, and then any communications out to the internet would transverse through a demilitarized zone, or DMZ, where you might have DNS servers that are sending out queries and caching that information. Of course, firewalls, your web servers and email servers exposed to the internet, really the area where you're interfacing between the WAN and the internet in general. But the DMZ provided a mechanism to provide some controls and security, essentially build a security fortress to protect against the attacks coming in from the internet, and to enable monitoring of connections and communications going out to the internet. Now, with the onset of cloud and cloud providers providing multiple interface points throughout the globe, really, you have now these points of presence of various cloud providers that are perhaps closer than the DMZ. But the problem is that using a traditional network topology, such as the WAN connected to the internet through one or two DMZs, is that you end up routing traffic through the DMZ. So while the site A may be down the street from POP A, you still have to traverse all the way to your DMZ, which may be on the other side of the country or the other side of the world, and then back out to the internet and maybe to a different POP that's closer to the DMZ and not necessarily to site A. Likewise with site C, and then maybe in an extreme case for site B, which again may be trying to connect to a POP that's relatively close by, but by necessity having to traverse through the WAN to the DMZ and then out to the internet to the cloud POP. So again, whether it actually goes to cloud POP B or let's say cloud POP A, you're still traversing the WAN and adding that performance penalty. So this is one of the ways that SD-WAN can actually help resolve some of these pitfalls of the WAN backhaul. So here we see where the site A can connect directly to POP A, and likewise B and C as well. And the benefit here is that now I've got this direct connectivity. I'm closer from a routing perspective, and that's going to improve the rate of transmission, if you will, of my packets between my sites and my cloud POP, so thereby improving my performance overall. So the way this, you notice these arrows aren't traversing the WAN, and this is just an example of what's called Internet Breakout, where I'm perhaps at site C, B, and A, I'm actually connecting not over to the WAN, I'm using a different interface on the SD router to connect to the internet, which enables me to connect to my local POP. So the benefit of this Internet Breakout configuration is first it's characterized by you're bypassing your WAN to connect directly to the Internet. And it's actually recommended by major cloud providers, including Office 365, for example, for optimal performance, so that you can connect to the site to which you are closest and able to enable that improved performance. The SD-WAN router will support the intelligence to provide that routing between the WAN, selecting the WAN or the Internet or other interface. And it also enables that optimal packet routing efficiency without the WAN backhaul. So you've got an exit point where you can go to your local ISP, to your local cloud provider, without having to go traverse the entire WAN. But there are, as with every communications technology, there are always trade-offs. So with the Internet Breakout, some of the again characterized by direct Internet access from each site, some of the pitfalls are that it bypasses that fortress we talked about in terms of the DMZ. So you've got all these controls that you've implemented and over years built up this cache of security controls that are now distributed to every site that has Internet Breakout. So it makes for a wider attack surface for attackers attempting to gain access to your network. So are these breakout sites as secure as the DMZ was? Or do they now serve as an easier target for an attacker to break in through this, quote, back door to gain access to your enterprise network? Of course, there are SD-WAN router security measures that you can put in place, including firewalls and the like, that you can help to control some of that. But it's also a good idea to add another layer of security to your defense in depth strategy. So typically, a good security strategy not only relies on one type of defensive mechanism, such as a firewall, where you're monitoring the data traveling between the end devices. With every transaction typically involving a DNS query to start, it's a good idea to add security to that layer so you can catch potential issues at the DNS layer and then have a secondary layer at the data transport layer. So adding defense in-depth strategy supported by DNS is a recommended approach to help improve the security of these Internet Breakout sites that might otherwise not be as secure as your DMZ. So this local DNS concept residing at each Internet Breakout site is actually provides that ideal query routing to the WAN. DNS can also forward internal queries to the WAN, so for your internal intranet, for example. You don't want those going out to the Internet, so it gives you the ability to forward internal queries locally into your WAN and only send out queries for Internet or cloud-based destinations to the Internet. It also enables that optimal resolution if authoritative DNS is also configured, if it's got local zones configured. And then it also adds the opportunity for that additional security layer that can be added for vulnerable Internet Breakout sites. So for example, if you implement a DNS firewall on that local DNS server, you can detect malware within that site that is attempting to contact the command and control center through the Internet, and the DNS firewall can help detect that. It can also help to detect and stop data exfiltration through DNS tunneling, use of the DNS protocol to actually encode and transmit sensitive data out of the organization. It can also validate DNS answer authentication and integrity with DNSSEC, assuming the responses are signed with DNSSEC. It can also help to mitigate denial of service style attacks with inbound and outbound rate limiting so that you're reducing your impacts there. And also control access to DNS functions with access controls, whether on the DNS server itself or at the DNS application layer in terms of controls for various types of queries and so forth. Of course, Diamond IP, our organization, enables several deployment options for SD-IPAM, software-defined IPAM, which naturally dovetails nicely into the concept of SD-WAN. So we basically have a couple of different options where we offer centralized IPAM, centralized IP address management with what we call IP control. That's our centralized management solution. In essence, the SD-IPAM brains that resides in the control plane. And then you can have distributed DNS servers in your data plane at your SD router sites. So at some of these SD routers support virtualization platforms embedded. So whether it's support of VMware or KVM or other virtualization platform, we offer virtualized network functions that you can implement there, either on the SD router or on another local compute resource, to enable the simple implementation of a virtual DNS server. We also have a Dockerized version if it supports a container architecture. There are some differences, though, in these deployment options. With the SDIPAM VNF, it's basically an appliance where we have really a lot more control than a container, where we're really just providing the DNS service itself. With the VNF, we have more control. But with both, you get the centralized control of the centralized IPAM, you get query forwarding, internal, external, also supporting the DNS firewall and DNSSEC validation, so you can configure that all centrally through IP control. DNS tunneling, however, is a function of our appliance and is only available in the VNF option, whereas the Dockerized version, again using the native ISC DNS, does not support tunneling detection nor inbound rate limiting configuration. It does support outbound, so for reflector attacks and the like, you can get that with both options. Anycast addressing, again, that is something we support with our appliances, not necessarily in the stock ISC version that we've Dockerized, and likewise with SNMP, MIBs, and traps. Also with the managed service option, so we can basically manage and monitor the entire infrastructure, again available with the VNF option. Now in both cases you do require an IP control license so that you can centrally configure and manage these. We don't license by the number of DNS servers you have deployed, so that's certainly a good thing. And actually the additional price on top of the IP control license that you would have to purchase for the Dockerized version, it's free. So we offer, it's on Docker Hub, you can download it, install it, hundreds if you like, across your local DNS Internet Breakout sites. But with the added benefit of the features that we've checked in this table, tunneling detection, rate limiting, OSPF, and BGP, Anycast, etc., there is a moderate cost of around $120 to $160 per month per site for that added benefit. So in either case, you can better secure your SD-WAN implementations by adding an SD-IPAM layer, and particularly a DNS defense in depth layer to better secure your SD-WAN deployments. For more information or further details, please feel free to contact us.